Talking about chemical reactions, alright? G Money, Dockside. Here we go. 1, 2, 3, 4. Chemical reactions everywhere you go. So chemistry, chemistry, chemistry. Hey. 1, 2, 3, 4. Chemical reactions everywhere you go. So chemistry, chemistry, chemistry. Hey. Like an electron, hopping all around to each chemical bond. First spontaneous, no energy needed. Non-spontaneous, you know I was heated. Sort of reactant, now I'm a product. Chemical bonds we build and destroy. Single rep, we switch in only one element. Double rep, we switch both for the hell of it. Dockside, I know he on to be. He got jank socks all up on his feet. Synthesis combine two and make one. You know chemistry raps are so much fun. Yeah.
Gabby, Samantha, Shanice's chemistry lesson, yo. Part 1, how to go from two reactants to the molecular equation, to the complete ionic equation, to the net ionic equation, and how to determine who the insoluble salt is. Step 1, this is how you go from two reactants to the molecular equation. We go A, B, C, D, and then you put A, D, and B, C, and just rewrite it. To see which reactant is insoluble, look at the back of the periodic table at the solubility of common ionic compounds in water chart, where it says FAQ, it's soluble, S insoluble. To go to your ionic equation, you break down the compounds and find the charges. So you break down, so it's 2Na plus Cl, yada yada. And charges 2, and then find for the net ionic equation, you find the insoluble compound and rewrite with reactant to product. So it is PbCl. So then you do Pb plus 2Cl reacts to PbClS.
So in part 2, you're going to learn how to read a solubility graph. To read a solubility graph, you will first see the curve on the graph. Most likely, it will be soluble in 100 grams of water. If the point you are at is above the curve, then solution is supersaturated. If the point is on the line, it will be saturated. Last but not least, if the point is below the line, then it's unsaturated. An example is KNO3, the solubility graph, and on the bottom is temperature degrees in Celsius. So you start from 0, 50, 100, 150, 200, 250, 300, 350, 400, and on the bottom 0, 20, 40, 60, 80, 100, 120. So on the bottom you see it says unsaturated, on the line saturated, and on top supersaturated.
This is part 3. How does temperature, agitation, surface area, and pressure affect solubility? Pressure affects solubility because as the temperature increases, the solubility of a solid in a liquid increases. Also, as the temperature increases, the solubility of a gas in a liquid decreases as well. As the surface area of a solute increases, the solubility of the solute decreases, and it takes more time to dissolve the solute. As the surface area decreases, the solubility will increase. Pressure doesn't have a solubility of solid or liquids. It's only soluble in gas substance. Agitation affects solubility by stirring or shaking something. The kinetic motion would increase. Therefore, the solubility of agitation would increase.